Hi Unite, welcome back to the channel. Today we are doing a quick lesson on looking at some ways of recording data rather than just writing it down by using some different types of graphs and displays. Alright, so here's our first one. It's called a stem and leaf plot. These are really useful when you've got a large number of data points and you've got a lot of two-digit numbers. So how they work is in this top row we've got a 0, 1 and a 2. What these scores actually represent is a 30, a 31 and a 32. So the stem is often going to be the tens part of the number and the leaf will often be the units. So rather than having to write this three times, we just write it once. And so we read this as 30, 31 and 32. Okay, so this is a stem and leaf plot recording how many refreshing cans of Pepsi Max were drank by some Year 9 students in the last 12 months. Thank you to Pepsi Max for sponsoring today's episode of Mathematics. I appreciate your support. So here's our stem and leaf plot. We're going to start off by finding the mode. So is there any score that is occurring more than the others? Well, we can see right here, we've got a pair of 4s right here, which means this 44 is happening twice. So that must be our modal score. So 44 is the mode. Okay, let's think about our range. So remember the range is the distance from the highest to the lowest score. So our highest score is 98 and our lowest score is 30. So if we do 90, take away 38, we get an answer of 68. So there is our range. And one more question, we'll find the median of this data set as well. So we have 21 scores. We can use our trick from the last video. If we do 21 plus 1, we get 22. Divided by 2, you get 11. So we're looking for the 11th score. So 11 is going to be the middle of 21 numbers. So if we count up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 brings us to the 54. So there is the median of our data set. Okay, for our next one, we have a histogram, which is a fancy mathematics stats term for a column graph that displays numerical data. That's what a histogram is. So the way we read this is the scores along the x-axis and then the heights of the columns represent the frequencies. So this histogram is recording data on the number of annoying TikToks made by 55 12s in a 48-hour period. So an example of how we could read this is if you're wondering how many people made 5 TikToks, well, 5 TikToks has a frequency of 8, so we had 8 people doing that essentially. Okay, we're going to find the modal score from our data set. So histograms make questions like this very, very simple because you can quite clearly see which of our scores has the highest frequency because it has the highest column. So the score of 6 occurred 14 times, so there is our mode. A little bit tougher now, we're going to calculate the mean, and so recall from the previous video that the mean is the sum of all your scores divided by how many scores you have. So let's take a look at this first column. Our score of 3 is occurring 4 times. So imagine if we had wrote that out, we'd have 3, 3, 3, 3. If we added those up, we would get 4 lots of 3, so we would get 12. For the next column, we have the score of 4 occurring 7 times. So if we had written out 4 7 times and then added them up, 7 lots of 4 would be 28. So similar to the last video where we were doing the scores multiplied by the frequencies, we're doing a similar thing here. So the score of 5 happening 8 times is a sum of 40. 6 happening 14 times, 6 14s are 84, which is also 7 lots of 12. And then for the last column, we have a score of 8 happening 10 times and 8 10s are 80. So if we add up these 6 blue numbers, we'll have the entire sum of our data set, which works out to be 328. We'll divide by how many scores we have. The question already gave us a hint that there were 55 12s surveyed, so there should be 55 scores. However, if we do 4 plus 7 plus 8 plus 14 plus 12 plus 10, we would get 55 if we didn't know that from the question. Okay, 328 divided by 55 works out to be about 5.96, and there is our mean of the data set. Okay, and for the last part of this question, we're being asked to draw the frequency polygon. So a frequency polygon is essentially a line graph that traces out the shape of your histogram. So the way we construct them is we're going to put a few dots on our display. We're going to put dots at the center top of all of our columns, okay? We're also going to put a dot at the start of the graph and at the end of the graph. And now all we need to do is link these red dots with straight lines using our ruler. And there we have our beautiful frequency histogram. So we could take away the histogram and we'd be left with a line graph that shows us the distribution of our scores, is essentially the idea. Okay, up next we're going to talk some new words about how we could describe different distributions, how we could compare them. So we've got two dot plots here and a histogram, and we're going to talk about the skewness, modality, clusters, and outliers. Okay, so the first word is skewness. Now, skewness talks about whether your data set is stretching in a particular way. So the way we see that is we sort of trace around the shape of our display. So this first one, if we draw around a little shape, we can see a definite tail pointing in the left direction. Now, if you think about your number line, towards the left of your number line, you have your negative numbers, and towards the right of your number line, you have your bigger, more positive numbers. So because the outline of this histogram, of this dot plot, has a tail that's pointing in the negative direction, we describe this data set as negatively skewed. Okay, so you trace around your data set. If the tail is pointing to the left, you've got negative skew. If your tail is pointing to the right, you've got positive skew. So skewed essentially means stretched. For this one in the middle, once again, we'll draw a curve around the outline of our graph, and we can see a tail pointing towards the bigger numbers, which is in the positive direction. So this middle one has positive skew. And on the end, our third dot plot has a bit of a weird shape. If we trace it out, we don't really see a stretch in either direction. It is a bit of a weird shape, but it is pretty symmetric about the middle. So when you don't have any skewness, you've got a symmetric data set. Okay, the next term is modality. So modality is related to your mode, which is where your peak in frequency is. So when we're talking about the shape of a distribution, the modality is essentially how many peaks it has. So this first data set, we can see a modality of 1 because we have one peak in our data set. For the second one, once again, we have only one peak and a bit of skewness. So we have a unimodal data set, means one mode or one peak. And for our third one, we have two peaks. And so the way we say this is we call it bimodal, two peaks. Okay, up next is clusters. So when we're talking about clusters, we're saying what are the numbers where the majority of the frequency is occurring, or where is your mode occurring essentially. So for our first data set, we're seeing a cluster of scores around the 8 and 9, which is where we're having this bunch and having this peak. So we would say this data set is clustered around the scores of 8 and 9. For the middle one, we have a cluster around our peak of 22. And for the third one, we have clusters at both 4 and 6, which is where our two peaks are for our bimodal data set. And the last term for today is outliers. So outliers are scores that are separated from the rest of the pack. So outliers are lying out by themselves, either significantly above or significantly below the rest of the data set. So for our first data set, we do see a bit of a gap between 1 and 3. It's not a massive gap, but there is still a gap here. So we could call the 1 here technically an outlier. It's a bit of a stretch because it's not very separated from the pack, but it is still having some separation. For the middle data set, we don't see any scores that are separated from the rest of the group, so we say there are no outliers. And for our third data set, we can see a fair gap down to the 1 score and up to the 10 score. So we could classify both the 1 and the 10 as outliers in this data set. Okay, we're now going to do a quick question on how we can compare two data sets using the same stem and leaf plot. So in the bottom right hand corner here, we have two plots of leaves coming off a single stem. This is called a back-to-back stem and leaf plot, and it's how we can really easily compare two data sets by looking at them and comparing their size and shape. So these are the travel times on a road. We have two data sets. The first one is the travel times when there's tolls on the road, where you have to pay for your car to be on the road. And the left-hand data set is the travel times when there are no tolls. So we can see a few clear differences, which we'll talk about later. To start off with, we're going to calculate or figure out what the modal time is when we're traveling with tolls. So modal time means we are finding the mode of the data set. We're looking at the traveling time with tolls. Sorry, without tolls, so the left-hand data set. Have a look here, see if you can spot what the mode of the left-hand data set is going to be. If you're looking at these 4 repeated 2s and you're saying to yourself, well, because they're coming off the stem of 5, this must be 52 happening 4 times. We've got a couple of double ups, we've got a 3 happening 3 times, but the only quadruple is the 52, and that is our modal time. For question B, we're going to find the median of the time with tolls. So the right-hand data set, we're going to find the median. We've got to find out how many numbers there are. If we counted all these, we would find there are 30 scores. So where would the middle of 30 scores be? Well, we'd have 15 in one half and 15 in the other half. So the middle score is going to be between the 15th and the 16th score. So if we count up, the 52 is the 15th score and the 54 is the 16th score. So the median is halfway between these two. So we have a median time of 53 minutes. And last question, which we're not going to do on screen, we're just going to talk about it, is we're going to compare the data set in terms of skewness and spread. So let's talk about skewness. How would you describe the skewness of the left hand without Toll's data set? Are we seeing a stretch in either direction? Not really. So this is a data set which is pretty symmetric based on the plot that we're using. So we would not be saying there is any skewness in the left-hand data set. In the right-hand data set with Toll's, if we trace around it, we can see there is a bit of a stretch towards the higher numbers. And when you're stretching towards the higher numbers, that's called positive skew. So with comparing these two, we could say the Toll's has positive skew and without Toll's has no skewness because it is a symmetric data set. Okay, now talking about spread is looking at what numbers your data is spread over. So the without Toll's data set starts at 39 and it only goes up to 61. So we don't have a massive amount of spread there, only a range of 22. If we look at the with Toll's data set, however, our smallest score is 35 and our highest score is 60. So we have a much larger range of 55. And as we can clearly see from the picture, the with Toll's data set is more spread out because of this skewness. Okay, so what the question is fishing for there is for us to say positive skew, no skew, and we want it to say small range, not very spread out, and this is a larger range because it is more spread out due to the skewness. Okay, to finish off this video, we're just going to do a question looking at the impact of outliers and why we care about what outliers are. So we have the annual salaries, so the yearly pay of 7 people recorded below. We've got from 65,000 all the way up to 180,000. We're going to start off by calculating the mean and the median of these 7 numbers. You're encouraged to pause the video and do it for yourself if you want a bit of practice. Otherwise, here we go. All right, so the mean, remember, Greek symbol, mu for mean, is the sum of the scores divided by the number of scores. If we add up the 7 numbers, we get 630k. Divide by 7, we get a mean, so a numerical average of 90,000 annual salary. Now, if we look at the median, when you have 7 numbers, you're going to have 1 in the middle, which is the $77,000. So let's talk about this mean. If you gave me these 7 people and you told me their salaries, and then you said this group of people have an average salary of 90,000, why might that be a bit of an issue? Why is it an issue to say that the average of this data set is 90,000? Well, the issue is that out of our 7 scores, 6 of them are below average. How can 6 out of 7 of your data set be below average? So what we're saying here is that the reason we care about outliers is because they have a massive impact on the mean, which is what most people think of as the average of a data set. However, the median is also an average. It's just a positional average rather than a numerical average. So in a data set where you have outliers that are having a significant impact, sometimes the mean is not going to be a very good representation, but the median will be a very good representation. So you see this in a place that's commonly used is real estate agents. When they're advertising a certain suburb, they won't tell you the average, or sorry, the mean price. They'll tell you the median price, because the average, or the numerical average, which is the mean, is being inflated by the really, really expensive mansions, and it's making the suburb seem more expensive than it is. Whereas if they give you the median, you get a more achievable number. So let's recalculate this process and let's cross out the 180,000, and now we'll calculate the mean and the median using only these 6 numbers. Let's have a look. So the mean, now if we add them up, we have a total of 450,000. Divide that by 6 and we get a mean of 75,000. Now for our median, we've got 6 numbers, so we're going to be between the 3rd and 4th score. Halfway between 72 and 75 will be $74,500. So now that we've taken the outlier out of commission, we can see the mean and the median are much closer together. So we have a much more symmetric data set, and it means that our mean is not being thrown off by our outlier. And this is important. This is what happens in real life stats when people are collecting data and calculating averages. The first thing they do is they identify outliers and they scrap them from the data set because they have a significant impact on your stats, like your mean, for example. So the reason we care about outliers is because they ruin our stats, and you've got to figure out where they are first, so you can scrap them, and so you get more reliable statistics based on your averages and your location. All right, cool. So there are some practice questions for you guys to go on with, posted to Google Classroom. Please let me know if you need a hand with any of those questions. Otherwise, I'll see you guys later. Thank you for watching. Bye.